Okay, suppose we want to make an inch versus feet graph. One of the first things you want to do is title your graph at the top. That's actually worth points on the test, so I'll call it an inch versus feet graph, because that's what this is telling us. And the first word always belongs on the y-axis. The y-axis is up and down, so that's how many, what we measure in inches, and the unit you want to also put, but our unit is also inches. The same thing with feet. Feet is going to be on the x-axis down here, and we measured it in feet. Usually it looks a little bit different. This is sort of a first intro graph. We want to label, put the axes numbers. You always want to have the origin is 0, 0 to make sure that stays 0, 0, but somehow be able to fit all our data in that graph. The length in inches goes up to 120, so somehow I need to space this so that 120 fits on the top. You could do it with trial and error, like think, well, if I go by ones, is that going to fit? Not really. If I go by 100s, that would be 100, there's 200, that's going to be too small. So you want to space it so that your graph covers at least half of your graph. I would think maybe going by 5s would be pretty good, and that's why you're going to use pencil, because if you mess up, you just redo it. But so that means every 2 lines is 10, so there's 5 and 10, so it'd be 20 here. This would be 30 here, and so on. So there's 40, there's 50, there's 60, there's 70, there's 80, that's going to be 90, that gets me to 100. Actually 100 doesn't quite work because I need to get up to 120. So I'm just going to use the back button, but you would erase all that if it was in pencil. Maybe I could say every 3 lines is a 10. Or every 2 lines is, say, 20. Now my pen won't work. So this is 20, that's 40, 60, there was my writing, sorry, that's 100, that would be, right here would be 120. Okay, you do the same thing with length in feet, that goes up to 10, so you want to spread that out, so 10's at least half the graph or more. So maybe every 2 lines is going to be equal to 1. So this line right here would be 1. This one would be 2, and so on. So there's 3, that one's 4, that one's 5, that one's 6, 7, 8, and there would be 10. To plot your points, well, length of 25, and then 2 and 1/12 of a foot, you go up where 25 would be. Well, if this is 20, this would be 30. 25 would be in the middle of that. I'm going to go over to 2, and 1/12 is a little bit more than 2, so maybe right about there would be my point. I do that with the book. That goes up to 12 and 1, so 12 is a little bit more than 10 over where 1 is, so maybe right about there. Made that dot a little too big, sorry. And then 65 and 5 and 5/12. I go up where 65 is, and where is 5 and 5/12? So this would be 5. 5/12 is almost another half, so maybe right about here. And then I have 120 and 10. So here's my 120, and here is where it lines up with my 10. So there's my point. The next thing you want to do is to draw the best fit line through this data. That's where you want to take a ruler, and I can't really show you taking a ruler, but I'm going to take a ruler here and try to trace as best I can what line best represents that data. I wish you could see this, but to me, as I'm taking this ruler, I'm thinking this looks like about the best line. Not every data point crosses that, like this data point doesn't, and this doesn't, but in general my line is doing this. If I were to do it again, I might make my line a little bit further down to get a little bit closer to that dot. After that though, you want to be able to find the slope of this line. If you do that, don't look back at this data. You want to pick 2 points on your line that line up with the axes pretty evenly. So I might look at this point right there and then pick a point further down the line, maybe this point right here. And I'm picking those because they line up right on the axes here. So this point right here, I want to call it X, and it goes up to 4 in the X direction. And then my Y, well, it's between 40 and 60, that says, fix that, so there's about 50. So 4, comma, 50. In the other number, that goes up to 9, and then it goes up to 120. No. You know what, I actually graphed this point a little bit off. This should have been where it was at. But, so yeah, that's going to be 9 and 120. We'll see how accurate this looks later. You then want to put it in the formula for slope, and you can show this right on your graph. The formula for slope is y2 minus y1 all over x2 minus x1. You want to label these numbers though so that you're not going to make careless mistakes. This is my first point, and here's my x of 4 and my y of 50. I'll call this x1 and y1. My second point, well, there's an x right there, the 9. I'll call that x2, and my other one, the 120, we'll call that y2. So I fit it in this formula, and I'm going to take that 120 minus 9 and divide by, I'm making a careless mistake. Y1 is 50, so I'm going to take 120 minus 50, and then take my x2 of 9 and subtract my x1 of 4. When I do that, I'm going to get 70 over 5. The next thing I want to do is put that in the calculator. If I take my talking calculator here, 70 divided by 5.
70 divided by 5 equals 14.
Okay, I get 14. This also has units to it though. 14 what? Well, my y's were measured in inches, and my x right here, those were in feet. So my numbers on here, my y's are in inches, so that would be 70 inches here, and my 5 would represent so many feet. So in the end, I end up with 14 inches over feet, which tells me that there's 14 inches per foot according to my graph. Again, I didn't graph very accurately, and this point right here I accidentally put a little too high. It should have been down there, and that probably would have made my line a little bit sloped a little bit further down, and it would have had a number closer to 12. But you get the idea here of what to do, and if you're more accurate, it's going to be closer to a good value there. I hope that helps make a graph, and that's it. Okay. Oh, one last thing to write the formula for this line. The general equation of the line is y equals mx plus b. What I would do is y, in this case, my axis is measuring inches, so that's telling me that inches, my y-axis, is m, and m represents the slope, and right here it's telling me it's 14. Again, not very accurate, but close. The x represents this x-axis, and we were using feet for that. So we'll say times feet, and then the b, the plus b right here, that's the y-intercept. And it pretty much crosses at the 0 on the y-axis, so that would be plus 0. So in the end, I get a formula that kind of is like a physics formula. It's telling me the number of inches in something would be 14 inches per foot times the number of feet. So if I had 2 feet here, and I multiplied by 14 inches per foot, that would tell me how many inches I have. Again, we all know that this should really be 12, but I had a little bit of an inaccurate slope here, and that changed this number a bit. But you get the idea, and I hope that helps.